Welcome to Fragmented, a software developer podcast where we talk about building good software and becoming better developers. My name's Donn Felker.
And I'm Kaushik Gopal.
Welcome to the show. Hey everybody, before we get going, I wanted to tell you about a brand new resource that I released. It's called Mastering Git. It is a free Git course that will teach you everything that you need to know on how to use Git from the ground up in less than 120 minutes. It's super easy to follow. You don't need any specific tools installed other than Git itself. I'll teach you everything you need to know from the ground up using the command line and the 20% of commands that are going to give you over 80% of the benefits for you and your day-to-day engineering career. Now, there's a ton of Git commands out there. You may not be sure which ones you should use. I've been using Git for over 12 years now from the command line, and these are the distilled down commands that I use on a day-to-day basis. I'm going to show you how to use each one of those, from initializing repositories, making commits, how to create branches, conceptually what are branches, how do they work, branch naming strategies, how to merge, how to utilize merge tools, how to handle merge conflicts, how to merge branches, how to create pull requests on things like GitHub, how to cherry pick, how to view logs, how to create aliases, and so forth. I cover all of that within this course. There's no fluff in it. We hop straight into it, and you're going to learn everything that you need to know in order to become a master of Git. Again, there's not a lot of commands that you're going to learn. This is the course that I wish that I had when I started. Doesn't matter if you're a beginner or if you're advanced, you're going to learn something for this. However, if your team member is new, or you're just learning Git, or you want to be able to kind of understand it better, this is the course for you. So check it out. The link is going to be in the show notes. You can also view it at donnfelker.com/git. You'll be able to see a nice demonstration of what is inside of that course on that page, and it'll link you directly to the actual video itself, which is free on YouTube. You can also visit my YouTube channel, which is going to be at donnfelker.com/YouTube. You can find it there too. So again, go to donnfelker.com/git for the free Git course and learn Git and master it. And I really hope that it helps you. Let's hop into the show. Everybody, welcome to Fragmented. Today, I'm going to be continuing. This is going to be the second podcast where I talk about working effectively with legacy code by Michael Feathers. This is, again, by far probably my favorite programming book that I've ever read, mainly because, and again, to reiterate this, it is really, when people hear the title of it, they think, oh my God, that sounds boring. Legacy code. I don't want to work on legacy code. Here's the thing though, regardless if you want to work on legacy code, if you are working in any software project, you will touch legacy code. Again, so what is legacy code? There's many different definitions of it, but I really like the definition, this general definition, that legacy code is code that doesn't have tests around it. I kind of really like that. Now, I also agree that legacy code is just older code that's just out of date and needs to be updated and maybe follows an old programming paradigm. So I think that applies too. But let's just say, for the sake of this example, just for simple purposes, it's code that you didn't write and it's older code and you have to interact with it and it's been around for years. You're going to encounter this stuff on a day-to-day basis. And understanding how to work with that code while you're writing new feature code, while you're creating new things in your company's code base is key, because you're going to run into situations where you don't know how to change things. And it seems really difficult to get something under test because the way that the old code was written was not written with testability in mind. And this happens with a lot of systems, especially when they're built from consulting companies that are paid to just really get the app done at all costs and cut corners. That happens. I'm not saying it's right, but that's the reality of the world that we live in as software developers. I'm sure we've all opened up a file or a project and kind of just put our head in our hands and said, what is this mess? Or what did I get myself into? Why am I doing this? This is absolutely bonkers. I don't want to do this. So understanding how to work with that code that's in a legacy manner like that gives you a ton of confidence, because you can look at it and say, okay, I need to interact with this class. It's completely tightly coupled to a database, a network layer, all kinds of junk. But I need to get this under test because this is a really complex feature and we need to make sure that this thing is done correctly. And of course, we're writing tests to do that. And so to continue on, the last episode of Fragmented, I talked about the legacy code change algorithm. And so if you haven't listened to that, check out the last one on working effectively with legacy code. And that one is just titled The Legacy Code Change Algorithm. Now I'm going to hop forward here in this book here, and I'm going to skip a chapter actually, because I think this is probably one of the most important chapters of the book itself, because it literally lays the foundation for literally all code changes you're going to do inside of a legacy system. And that is introducing what's known as the seam model. And this is in chapter 4 of Michael Feder's book, Working Effectively with Legacy Code. And throughout chapter 4, Michael talks about different types of seams. And what really is a seam? I think we should cover that first, just so you understand what that word really means. And a seam, as he defines it, is a place where you can alter behavior in your program without editing in that place. So you can alter the behavior of the program without editing in that place. So what does that mean? It's kind of confusing. You can interpret this in a number of ways, and there's different seam models which Michael introduces here, which I'll talk about in a second. But the way that I like to think about a seam is almost like a seam in some clothing. If you have a pair of jeans on, you can look on the side of your jeans and the fabric has a seam on it. It's sewn together. That's a seam. Right there is a point where I can potentially kind of wiggle that apart and perhaps get something else into that seam. And so in code, this might be where a couple of classes talk. It might be where some methods talk. It might be where things interact. And there's different types of seams. And Michael has 3 different types of seams that he talks about. And they are a pre-processing seam. And he gets into the pre-processing of compilers, stuff like that. The link seams, which gets into linkers of compilers and so forth. And then there's object seams. Now, I'm not going to dive into each one of these. I'm not here to rip off his book completely. I am going to advise you check out the show notes and you buy this book yourself. It's been on my shelf since, I don't know how many copies I've bought, probably 2 or 3, and I've handed up. That's one of the books I give and buy to any team that I manage, simply because it's that important. And even though it might have been written 10 plus years ago, the concepts in it are just so solid. So I'm not here to rip it off. I'm here to help you understand the concepts in it, to hopefully get you to change your mind and the way you're thinking about legacy code, and to potentially go pick up the book. I'm not sponsored by this, but go check it out. It's just one of those fantastic resources. Anyway, there's these 3 different seam types, but essentially I'm going to distill it down for you like this. A seam is a place where we can break apart some dependencies. That's the way I like to think of it, because that's what I end up doing in all of my clients' work, is finding these places where I have these tightly coupled dependencies and I need to break them apart. Now, let's give you an example. Let's assume that I'm building a system and this system needs to interact with a library, not even a library, maybe a class that was written 5 years ago. And this class, when I call the method on the class, unfortunately what happens is it makes a network call. And there's no way to prevent that. So thankfully I have access to that class, this old legacy code. It doesn't use any dependency injection. It doesn't do anything. And so inside of this method, let's just call it, an API that it talks to. And the API is another class it talks to. So everything's tightly coupled. And if you look inside of this method, what you see is they're newing up a new instance of the API and they're calling, API.fetchCustomers or whatever. So we'll go with that example. So inside of our method, that perhaps we are maybe calculating the average balance of a customer. It fetches all the customers, and then inside that method, it does the averaging or whatever the formula is. The problem is, inside of my code, I need to call this method, and then I need to do something with the result of that method. However, to get this under test, I don't want it to actually talk to the API. I want to be able to run this in a hermetic environment where I can control the inputs and the outputs. I don't want to have to worry about things like the network going down. Is the server even up? What if the response times out? There's too many unknown variables here, which make this really complicated. And it makes it really hard to test. And if your tests are not reliable, then you lose confidence in them. And what happens when you lose confidence? Well, you no longer trust them and they're not valuable anymore. So anytime you have this kind of leads into another topic, which we'll talk about another time, is if you have flaky tests, you need to fix those. You need to fix them completely as soon as you can. Unfortunately, some technologies are easier than others to work with. There's a lot of web technologies that are really easy to work with and really easy to isolate things with because testing is built in from the beginning. Unfortunately, then you have technologies like Android where testing is an afterthought. Some people are going to disagree with me, but that's the reality of the situation. And it can be really difficult. And unfortunately, a lot of folks who are listening here are Android developers. Well, fortunately, you are Android developers, but unfortunately, you've dealt with this problem as an Android developer. That's what I'm trying to say. You run into these flaky tests. Now, we do have an episode where we talk to Matt Runo. I forget what episode number it is. We'll have to link it in the show notes, where he talks about how he uses on his team Firebase, Test Lab, and Flink, and there's retry mechanisms built in for flaky tests. So there are ways to handle it. But what I'm getting at here is that an unreliable test suite is just not going to give you confidence at all, because if it continues to break, you're like, wow, did it really break? Is it really a problem? Or was it just a network flake? Let's run it again. It broke in. Let's run it again. Like, you don't want that. You want it to break and immediately raise an alarm and be like, okay, something broke. That's an alert. Let me see what's going on. Okay. So that's what we're trying to get to, is how do we get this weird class that calls into us an API to customers that news up an instance inside of the method? How do we do that? So there's a couple of ways to do this. Now, the way that I really prefer to do this is extract some type of interface or abstraction away. So what that means is inside of my legacy class that calls the API, what I'm going to do is I'm going to go and find the API class. And on API class, I might say, all right, what is that API? And what does it look like? And usually I'm just going to look at the class. I'm going to look at the members of the class. What's the function? So this one might be, fetch customer list, returns a list of customers. I can, at that point, and if I'm using Java or Kotlin, I can use an abstract class. I can use an interface. And I might just create the exact same method signature. And then I can have that API class implement that abstraction. So I'm changing the API class. I'm just changing it by adding an abstraction. And it really doesn't do anything. All that really does is say, hey, this API class implements this interface, or implements or extends this abstract class. And that method that is on that abstraction, which is, again, it's going to be in an abstract class and interface, is going to be fetch customers and returns a list of customer objects. So from there, now I've got that on my API class. Now, again, I'm still inside of this other class that fetches the customers and stuff like that talks to the API. So it's still newing up an instance of the API. I still have that problem. But now what I've done is I've given myself the opportunity to implement, I've kind of created my own seam. So I'm starting to create a seam. And what I can now do is I can see inside of that method, okay, there's a couple of ways I can handle this. Now, if I'm using a dependency injection tool, maybe I can wire up dependency injector. However, that can really send you down. You can open a can of worms doing that. So usually best to kind of take small bites here and improve as you go along. Don't try to just boil the ocean. Don't try to do everything that's perfect at first. Do small, manageable chunks to get your current implementation, your feature under test. So I got this API that's in this legacy class. That's the problem here because it talks to the network. Okay, I've implemented the interface. Let's just say I'm using an interface on that API class. Nothing's really changed there. It already has the implementation of it. So I've just basically added some extra code that's an abstraction. Now, what I can do is inside of that method, I can do a couple of things. The first thing, I can actually create an overload of that method. Same exact signature, same exact function name inside of that legacy class. And then inside of that method, it will have one argument, and it will have the API abstraction as the argument. And so this is just really dependency injection. I'm doing some maybe manual dependency injection. And all this allows me to do is through the method, provide some type of abstraction. And so I'm doing method injection. And I'm going to just say, hey, here's my API interface. And then what I can do inside of there is call into the other method that I want by providing this instance. So maybe I could set this as a local variable. So there's a couple of things I might need to do inside of this legacy class. I got the overloaded method that provides the interface of the API. Inside of that legacy class, I might just have a field inside of there that says API And either it's null or not null. If it's not null, I use that one. And then inside of that class, that's the original method call, what I can do inside of there is check to see, hey, do we have an API that's not null in the field? Okay, if not, use that one. Otherwise, new up a new instance that talks to the regular API. So I'm making minimal changes here. I'm kind of implementing a couple of small seams here. And then what I can do now is I've actually implemented a seam inside of my class. I can now, inside of my test, I've built my function, I've built my own class that talks to this legacy class. I can now set that API to be a mock. It can be a fake object, it can be whatever. It doesn't, I'm not going to argue whatever one you'd like to use that. But it's an implementation you control. It doesn't talk to the network. Provides values that you can control in a hermetic environment. Then I might execute my test. Say, okay, call my class that calls into this legacy code as well. Say, hey, calculate average balance. What's going to happen there is now I've provided my fake, my mock object or whatever. My class will then call into this legacy class. What that will do is it'll check to see if that API, local, the field variable inside of the legacy class, if it's null, if it's not null, use the field. And then it would say field, whatever, API.fetch customers. And that's going to return my fake values. Else, use something else. Use the default version. Or what you could also do, and this is very useful here, is on that field, you can do two things. You can just say API equals new API, and you just set that inside of the field. Now, it depends on the implementation of the class. Is there anything cached? Is there not anything cached? This is a case-by-case basis. You have to evaluate your code base to do this. So what we're really doing is inside of our, that'd probably be the cleaner way if you don't have caching or anything like that involved, and you don't have to worry about that, is in the field, you just say, hey, API equals new API. And that's just the same style of code you had in the method before. And then inside the method, instead of using the actual newed up instance, you gotta delete that newed up instance line and just say, use the field name, API.fetch customers. Then again, in your test, all you're gonna do is you're gonna use your setter injection method and say, hey, here's the API I want you to use, and you use your fake object. And what that does is it overwrites the, and again, this has to be a mutable variable. So again, some people are going to cringe, like, oh my gosh, what about immutability? I understand. We're working with legacy code, so we need to kind of take baby steps. We can eventually move in that direction. As we continue to change this legacy class, we will get there eventually. But these are baby steps, so we might have to introduce some mutability. That's fine. And that mutability allows us to change the instance variable to a fake, to a mock or whatever. Now, when our legacy code class gets executed, we simply just say API.fetch customers. And in our test, because we provided a fake or a mock, now we can control the result. We've removed that network call. We've removed everything, and we can control the result. We can say, hey, what happens when there's no customers returned? What happens when there's 5,000 customers returned? What happens when all the balances are zero? What happens when it throws an error? You can simulate all those environments inside of a unit test, and it's going to be very fast. You're not going to be talking to the network. This is a huge bonus here by introducing a seam. And this is exactly what I do for almost all my clients when I start working with them. Now, the only thing that's going to be different here is some people might say, well, that's great, but I'm working with a static class. And we've all seen this, and it's a real pain in the butt. In fact, this is in major frameworks, in frameworks you use daily. There's static classes that go out and modify files or talk to an API or do something, and you can't have that in a test. You can't have that in a hermetic environment that you can control. So what do? You basically are kind of going to do the same thing. So what I do in this situation, this does require a little bit more of some changing. So again, let's use the same example. We got that class that talks to the API. Maybe there's 10 instances of where the API is called in this class, but everything is all static calls. So it's like API.getCustomerList. Like how do you can't provide a new instance of, an API. Now, I get it. There are mock frameworks that allow you to do this. If you want to use that, that's fine. Use that. However, if I'm trying to really, make this some good quality code, I'm probably going to introduce some type of interface again. So what I'll do is I'll look at that API class, which is static calls. And then what I'll do is I'll create an interface that has all of the exact same calls with the exact same parameters. So maybe there's 10 calls on it, get customers, blah, blah, blah. and I will create an interface that has all those same calls. Then what I will do is I'll create an implementation of that interface. And I call this is what I call the static gateway pattern. Now, I don't know where I got that name from. If I heard it from someone else, I'm not even sure. But it's something I've been using for over a decade to help abstract away static calls. And there might even be a better name for it. I don't know. That's the one I've used. It's just the static gateway pattern. Because you want to get rid of these static calls. And so I've created an interface, has the same exact method names, same parameters as everything that happens in the static, the API class. It's all static. I create an implementation of the interface. So it might be, my API static gateway implementation. And again, I'm just using random terms. And inside of that actual implementation, each one of those methods has to be implemented, of course. What I do inside of there is I just call the static call. I just say API.getCustomers, API.update customer, API.whatever. I'm just going to use the exact static calls. But what this allows me to do is I now have this interface. So I'm still going to use the same exact calls I was doing before, but I'm introducing basically taking this API and creating a shim on, I call it a shim or a seam on top of it. And I'm wrapping it. It's also known as a wrapper pattern, actually. So I'm wrapping the API, which is a static API. Then inside of my legacy class, instead of actually using the implementation that requires me to have a static calls, I'll create an overloaded constructor. And in this constructor, what I will do is I'll use dependency injection, and it will provide the interface as a constructor parameter. And then what I'll do is I'll set that equal to the local field variable for this static, API. And this is going to be my interface. I'll say, API interface equals whatever is sent in through the constructor. Then I'll have perhaps another overload, which is just a regular constructor, of course. And inside of there, what that regular constructor does with no parameters, perhaps this class has no parameters for a constructor. I'll have a default constructor. And inside of that constructor, I'll call the overloaded constructor that provides the interface. And in that one, I'll provide a brand new instance of the static gateway implementation. So, use the regular API. So if anyone news up this class like they've been using it for the last 5 years, it'll still work just fine. However, if I want to use this class in something else, I can now provide my own mock implementation through an interface. Again, being able to mock out all the calls that I want. So it will take me a little bit of rework to do this, but I am not going to have to walk down this entire object graph and change everything. I'm basically going to wrap this, I call it static gateway pattern. I'm going to wrap this static call in its own interface and class, and I'm going to isolate it really. It's still going to do its exact same job, but it gives me this seam in the middle that I can start providing mocks or fakes against, etc. And this is going to give me the flexibility for anyone who wants to consume that class. I can just use this implementation, the static implementation as wrapper class, and it'll give me the same exact result, but allows me to control the test environment much easier. And then if anybody just news up the instance of that old static class still, it's going to call the default constructor, which will then provide the implementation of the static gateway implementation, which is just the static calls itself anyway. Those are literally the two methods that I use to introduce seams all throughout applications. Anytime I'm working with legacy code, it's either going to be through some type of method injection, or it's going to be through constructor injection and using fields. So it will require a little bit of code change. So it doesn't match exactly what Michael Fetters has here. Again, he talks about the different types of seams being preprocessor seams, link seams, and object seams. But these ones are the ones that I have used over the last decade with great success and have allowed me to move forward. Yes, it does introduce more code. Yes, it is things that you have to maintain, but see this as a stepping stone to better and cleaner code. So this is not the end result. We're just walking down the path to try to get to a place where everything is testable. Eventually, maybe when we have more time, we have the resources, we'll then go ahead and create the API as it should be created when we have the time to do that. Maybe it does use dependency injection and it's much more testable. But right now, this will give us the ability to simulate a very good design, which we can provide testability in a hermetic environment. So that's kind of the seam model at a really high level approach. You're just going to find the areas in which you can break it apart and start providing abstractions. This is the thing I use the most inside of all of my client engagements. And we're going to continue to work forward through this book and talk about different challenges that you're going to have, such as, hey, my class is too long, or this file is big and I don't know what to change. And we'll talk about each one of these things. But what you'll find is a lot of time, the underlying principle is finding a seam where we can get something in there. So I hope that helps. Again, check out the book, Working Effectively with Legacy Code by Michael Feathers. The link is in the show notes. Provide link to Amazon. You can check it out. I'll provide a link to the testing from the testing episode where I had with Matt Runo, where we talked about flank and kind of retry mechanisms and stuff like that. That was a good one. And in general, if you have any questions, feel free to reach out. Thanks for listening, and we'll catch you in the next episode. Thanks for listening, everybody. Before you get going, don't forget to check out my free course on Git. This is going to be the course that shows you everything that you need to know in order to get started. It is the 80-20 of Git. You'll learn the 20% of commands are going to give you well over 80% of the benefit. Heck, I'd even say over 90% of the benefit. In fact, these are the commands that I use every single day, and I rarely step out of these boundaries. To learn more and to watch the course, you can go to donnfelker.com/git or just go to donnfelker.com/YouTube and check it out there for free. I really hope you enjoy it.
That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.